I want to welcome you to our SOA Summit Expert Breakout Sessions. This is the session for Alistair Farquharson, CTO at SOA Software. Alistair, welcome back to SOA Summit.
Thanks, Vance. It's always good to be here.
In his post, Alistair spearheads product design and development and helps enterprise customers leveraging SOA, cloud, web services, and APIs. He is an expert in distributed environments and software lifecycles with a focus on governance, policy, and management. And in his session today, all this expertise comes together as he discusses APIs and SOA, making money and preventing failure. He'll talk about not only the infrastructure aspects of SOA and API, but the importance of policy to business success for both of these types of technologies, for both the business user as well as the individual stakeholder. So it's a really terrific session where we combine integration, infrastructure, and policy to show that they really do create more than just the sum of their parts. Just a quick reminder, if you haven't already done so, you can download Alistair's slides by clicking the button under the viewing area, and you'll see other related downloads there that Alistair and his team have brought with them. And to ask a question, simply type into the Ask a Question box. And now, Alistair, tell us about APIs and SOA, making money and preventing failure.
Thank you very much, Vance. So as Vance said, what I'm going to talk about is APIs and SOA, and I'm going to talk about how policies can help you make money and prevent failure. Policies by themselves and a discussion purely around policy is not very exciting. So I'm going to use a lot of use cases, and I'm going to try and describe how policies can apply to the real world and how they can really help you in terms of business, making business work, creating a business model around APIs and services, and enforcing the standards and controls that you need inside an environment. So I'm going to start by talking about the types of policies that we typically see. Then I'm going to go on to sort of describe the benefits of using policies and how you can enforce and define those policies in an environment. Now, the interesting thing is that policies apply equally to both APIs and services. Granted, there are different policies potentially for APIs and services, but they're still policies, and you still need a policy framework, and you still need to understand what those policies are. Many companies today have significant amount of discipline around how they build services and how they create enterprise services. But in terms of APIs, it's still a little bit of the Wild West, and people are building APIs from multiple lines of business. They're building APIs that are not successful. They're building APIs that are not secure, and they're not focusing on how they can actually create policies that govern and control and enable the APIs that they put in place. So I'm going to talk a lot about APIs and services, and I'm going to talk about how policy applies to both. So let me start a little bit with the role of policy. With the danger of being too dry, the definition of policy is that it defines the organization's objectives and provides guidelines for how to achieve those objectives. So in other words, policy is there to describe how to secure something, and then it's probably in a machine-readable format that actually allows you to secure messages or API calls or service calls coming in based on that policy. So if you look at an API or SOA context, these policies are ideally codified and enforced by a management product, similar to a product such as ours. And that product is there to actually take those policies, codify them, make them understandable by both human beings as well as machine systems, and its intent is to make life easier and to help prevent failure. The whole objective about creating policies and creating policy management systems is that you can write a policy and have that policy then enforced inside a runtime environment or inside a lifecycle environment, which makes that policy then automatically enforced, and it makes it something that you can manage as an organization and something that you have a certain amount of confidence that it's being applied inside a runtime environment to a set of APIs or services. Let me break down the different types of policies that we see. We typically see design time policies and runtime policies. Design time policies ensure that you build the right things and that you build them the right way. So when you think about APIs or services, it's making sure that you build the right APIs and services. In other words, services and APIs that are going to save you money or make you money or have levels of reuse or meet a particular business need or a particular channel's requirements. and that you actually build it the right way, that they are compliant, that they are well-defined. If it's a SOAP service, maybe it needs to be WSI compliant, or if it's a RESTful service, maybe it needs to have a good RESTful representation with resources and links and all of the things that you really need from a RESTful service representation, including documentation, etc. Then there's another set of policies, the runtime policies. And runtime policies have a huge gambit of variety. There are runtime policies that manage quotas and SLAs. There are ones that handle security and routing and mediation. And I'm going to talk a little bit about these different kinds of policies and particularly how they apply in certain real-world scenarios to the things that hopefully you as an audience are trying to do with your APIs and services. So let me start a little bit with design time policy. I mentioned a couple of examples, but let me break it down into more specific types. First of all, we have compliance policies. So is what I'm doing compliant with organizational standards? Or not necessarily organizational standards, but industry standards as well. Are my REST services beautiful and easily readable and resource-oriented? Are my SOAP services WSI compliant? Do I have good WSDL? Am I reusing schema? All of these kinds of things fall into the realm of compliance. Does it look like a good service? Then there's interoperability. So depending on the kind of channel you're trying to leverage or the kinds of systems you have internally, you want to make sure that people aren't building APIs and building services that aren't going to be compliant with the devices and the systems that want to use them. So there's very little point in building a .NET web service leveraging NetTCP, for example, if you want to consume that service from a Java environment. It's no point in creating SOAP services when you're trying to appeal to a mobile device channel. So you need to build the right service for the right consumer, and you need to make sure that your interoperability meets your business needs and your channel needs. Then there's things like classification. So how do I know what kind of services? How do I make it simple to discover? And that's done through classification. So you classify your services maybe based on reliability or uptime, operational parameters, or you might be classifying your service or your API based on functionality, technology, business need, partner channel, whatever you feel that you need to make that API or service discoverable. If you're exposing a developer portal, for instance, and you have a whole set of APIs to be used by mobile app developers, it's really critical that you tag those APIs appropriately so that people can find them. So you might have APIs or endpoints specific to a particular mobile device or business requirement, and you need to make sure that that is done appropriately during design and development time before that API is released into the wild. Then there's all sorts of things around certification. So how do I certify an API before publishing it? How do I certify an app before putting it into my enterprise app store? So there are workflow processes around certification that you need to understand and you need to encapsulate within a product. Then there's lifecycle management. So how do you manage the service and API lifecycle, how it's built? How do you ensure that the SDLC process is correct, that certain people are signing off at the right times? How do you manage your app lifecycle, the certification of apps, as I mentioned earlier, and ultimately the provisioning of apps to APIs or applications to services, both outside of your firewall and within your enterprise, but for app-to-app service integration. So these are the kinds of policies that we typically see during design time and development time within organizations. If you look at runtime policy, you end up with a whole different slew of policies. You're looking at security policies. This particular API requires OAuth would be an example of a policy. But more fine-grained than that, what kind of grants, what kind of credentials are required, what back-end identity systems need to be used. In terms of access control, who has access to what, protection policies, SQL injection, script injection, all of the kinds of threats and protections that you need to apply to APIs and services differently based on the policies that you want to enforce as an organization. What qualities of service are you looking for? So you can't just put an API out there with an unguaranteed and unmonitored and unmeasured quality of service. You need to somehow come up with at least a standard for quality of service and then a way to measure that quality of service appropriately and report on it. Then you need quota management. So you need to make sure that the right people are getting the right qualities of service and the right quotas associated with them. And this is there to protect your business and to provide licensing for your APIs and services. And I'm going to talk a lot about some of these things later on in our use cases. Other examples of runtime policies is caching, for example. You might want to cache globally for a mobile application. You might want to cache through a CDN system for binary content. So there's different kinds of caching policies depending on the nature of the API or service and the consumption channel that it's being exposed to. Then there's metering and billing, the flashing lights and the pretty charts and the reports that you need to actually derive value or to determine what value you are getting out of your SOA program or your API program. For an API program, you might want to see how many people are consuming your APIs. If you're monetizing APIs directly, you might need those reports to be able to bill for access to your APIs. For services, you typically want to measure how much reuse you're getting out of a particular service. So if it's being reused 5 times, you're saving $20,000, and that's measurable, and you can derive value, or you can determine the value of and the success of your SOA program within an organization. So all of these are good examples of runtime policies. So I kind of discussed design time policies and the runtime policies that are typically encapsulated or typically required by our customers and encapsulated within products such as the ones we provide. So up until now, I've discussed the various types of policies and the kinds of policies that we're seeing within our customers today. Now I'm going to try and make those policies real and talk about them in the context of use cases. The first use case I'm going to sort of cover is around mobile app packaging and publication. And we're seeing a lot more organizations with the advent of bring your own device and with the advent of the enterprise app store, customers are trying to instill a little bit more rigor and a little bit more process and a little bit more control into that app packaging and publication lifecycle. Up until now, most organizations haven't had a lot of apps. They haven't needed to actually control the app packaging and publishing lifecycle. But now we're seeing more and more apps, and we're seeing more and more enterprise app stores, so we're starting to see more and more need to actually control that lifecycle. So I'm going to talk a little bit about that because it's really, really relevant today. I'm also going to talk a bit about the API and service development lifecycle. So how are APIs built and how are services built, and what does that lifecycle look like? There's a process by which a service becomes an enterprise service, and I've spoken about this before, and I think that everyone who's familiar with SOA has an understanding that an enterprise shared service is more than just a service. It has a certain amount of discipline and rigor around it. We see the same thing with APIs. In fact, APIs require even more rigor and even more process, simply because APIs are something that are being published outside of your organization that reflect your brand and have certain expectations around them. There's an expectation that there's a level of documentation. There is a certain arm's length relationship between the API publisher and the app developer. And this requires a certain amount of supporting documentation and metadata around that API, and of course, a certain amount of business scrutiny to make sure that that API is actually delivering what it's promising to deliver. Then I'm going to look at licensing. Licensing is quite interesting, especially in the context of APIs, where organizations are monetizing their APIs in various ways, or at least controlling the fine-grained access to APIs and the documentation to enable different levels of visibility and different licensing models for their APIs. So I'm going to talk about licensing, and that's going to lead me into discussion around quota management. Because quotas are important when you have licensing models. If I have a gold, silver, and bronze license, I'm going to want fast and slow quotas associated with those licenses. So quota management is really interesting in terms of metering out or parceling out API or service access and protecting your application backends within your organization. Then I'm going to talk about a security mediation use case, which is typical within organizations today. How do you actually mediate between different security policies? All this trouble to describe these security policies, what is the extra bang for the buck that it gives you? What is the 1 + 1 = 3 of policy around security? I'm going to talk a little bit about that and the sort of magic that happens when you start describing things with policy appropriately. And then I'm going to talk a little bit about edge caching and paging as it relates to APIs and services, particularly for mobile devices. So this is the set of use cases that I'm going to cover, and hopefully it's going to cast a little bit of light onto the various policies and the usefulness within the organization. So first, a discussion around lifecycle management. And lifecycle management, as you recall, applies to both app packaging and publication, as well as to API service development. So lifecycle management is all about how do I build the right things in the first place, and how do I build them the right way. So I want to make sure that I have the appropriate business level sign-off, the appropriate funding, the appropriate prioritization, and then I want to make sure that they're actually built in a compliant manner and that they're going to appeal to the target audience, whether they're services or APIs. So I'm going to start with the app packaging and publication use case. So typically what we're seeing in the context of app packaging and publication is that an organization is trying to build mobile applications and publish them into the App Store. Now, if you think about this simplistically, you have an app development tool, an IDE, somebody builds an app, they compile it somehow, they create a set of binaries, they then push those binaries into the App Store depending on the type of App Store, and voila, you now have an app published into your App Store. There's a variety of different App Stores depending on the different devices, a variety of different channels, and varying levels of complexity. There's nothing that is consistent about how it's done, and by and large within organizations today, there is one person who understands the environment and the App Store publication process and who's responsible for actually getting that thing into that App Store and all of the metadata associated with it. So what organizations are faced with is how do they actually scale that? And how do they actually automate that process? Well, my goal here today is not to try and make your life more complicated. It's to try and actually make your life more simple and quicker and faster and more predictable and more transparent. So what we work with organizations on is how to actually automate this particular process. So let's look at what it might look like. So the first step might be approval. So at some point, you're building this application and you want to make sure that that application is actually approved, that it's approved to be published into the enterprise app store. It's a mobile application you've built and everyone gives it the thumbs up. Then there's some kind of a build process associated with that. There's an automated build system that takes the binaries or takes the source code that you have, builds it and packages it up. That packaging process might involve some post-compilation processing. We partner with companies that do post-compilation processing to sandbox an application or to prevent insecure applications from being distributed. So whether you're packaging SSL certificates and keys into an application, or you're making sure that that application does not support cut and paste one way or the other, then that can be done as a post-compilation step. Then there's all of the documentation that needs to be done for that application, all the metadata that needs to be collected before it can be reliably published into the App Store. So this is an example of an app packaging and publication process that we typically see within an organization. So to simplify and automate that app publication process, you need to cover a number of different capabilities within the system. You need to be able to do app key management. You need to manage the provisioning of apps to APIs. You need a system or a tool that will integrate with your IDEs. You need to integrate with your build systems. You need to integrate with any post-compilation processing. And you need to integrate with the App Store. And what this does, if you can come up with a system that manages all of these different capabilities, you can then control the factory for getting apps into the App Store. So what companies are doing is they're creating automated workflow processes that integrate with these different systems and push the application through these different steps with the appropriate levels of approval and sign-off at the various points in time, and ultimately automatically publish an app into the App Store. Incorporated in this workflow or lifecycle process are all of the associated policies. So what are the compliance policies? What do the app keys need to look like? What are the authentication mechanisms being used? What post-compilation policies do you want to put into place? Your sandboxing policies, your security policies, your privacy policies, etc., etc. What levels of documentation do you want and need? What are you going to force your developers to fill out in terms of metadata? And then ultimately, who controls the gates for publishing that app into the App Store? So the app packaging and publication process is something that is surrounded by and governed by policies, whether they be workflow processes or whether they be security processes or policies, and the tools that the systems integrate with. So this is an example of the kinds of things we're doing for our customers today to manage and automate the app packaging and publication process. And the goal here is to simplify that, make it more predictable, more transparent, and hopefully save you money and protect you from publishing apps that are compromised, that have no security, that have no standards, and no controls. The second use case is around API and service development lifecycle. If you think about APIs and services, it's very hard to think about APIs and services in isolation. There's a lot of things that surround a successful API and a successful service. If you think about all of the dependencies, all your legacy backend systems, mobile backend as a service, the mashups that support those APIs, the big data systems that the APIs are being exposed out of, the cloud environments that the APIs are running in. There's a large number of dependencies that you need to take care of when you're exposing a service or exposing an API. If you think about the processes involved in exposing an API or service, you have legal processes that make sure that all your legal agreements have their I's dotted and their T's crossed, and that all of the legal agreements align with the business model that you're trying to put into place. Then there's all of the financial processes, how you're going to collect money, who you're going to collect money from, what things are paid for, what things are not, how are licenses renewed over time to meet the financial requirements or the stated business objectives of a particular API or service. If you're looking at service consumption internally, what are the financial sign-offs and what is the exchange of costs within an organization to fund a particular service and to drive the return on investment? If you look at licensing, how do I license a service that's exposed to my B2B partner or an API that I use for a mobile channel? What are the agreements associated with that? And what are the different tiers of licensing associated with an API or service? Then there's documentation, legal documents, API documents, WSDL documents. How do I actually distribute these documents to my end user, to my partner? And how do I manage all of the supporting documentation that needs to be written to support an API or service that's being exposed? And then last but not least, the standards that I want to enforce, the compliance and the certification. How do I make sure that the services and APIs are being architected properly? How do I make sure that they are going to interoperate? If it comes down to something as simple and as banal as the types of transport and types of bindings that my service is using, make sure you don't use something that is not interoperable with a planned consumer of that service. So what we typically do for our customers is we create a development lifecycle. And the objective of this development lifecycle is to reduce complexity and speed up development. Once again, you're trying to automate as many of these processes as possible. So how can you allow or how can you provide a way to model dependencies within an environment? So how can I create a dependency modeling tool that allows me to track the relationships between a service and any downstream systems, between an API and the cloud environment that it's running on? How can I actually manage change over time? To manage change, I need to understand what my set of dependencies are down to the version level so that I can control that and I can identify what dependencies I have and what I'm going to affect with every change and what downstream changes need to happen before I can change. So the dependency modeling is critical within an environment to understand what the knock-on effects are of any kind of change within the system. You then need automated workflows. So how can I manage this process of capturing a new API, approving the development of that new API, defining the API, building the API, and last but not least, publishing that into a developer portal. The same goes for a web service. How do I initially propose a new service that needs to be built? Who approves that? Who ensures that it complies with the standards? How do I enforce certain architectural principles? And how, last but not least, does that service get published into an enterprise repository so it can be reused by other teams? These are processes that are codified into a lifecycle management tool and manages and ensures that that process is visible and easy to follow for developers and for managers within the organization. So automated workflows I covered. The other thing that a service development lifecycle needs to encapsulate is things like license management. So during the development of an API or service, you need to understand what licenses are going to govern the consumption of this service or this API. So if you're looking at B2B, maybe you just have one tier of licensing. If you're looking at internal, maybe you don't have any. But if you're looking for an API that you're exposing to the general public, maybe you have a free tier of licensing plus a freemium tier of licensing plus an expensive tier of licensing. And these different tiers of licensing are vitally important to encapsulate and to understand right from the get-go. So it's part of the approval process, it's part of the definition process, and it's part ultimately of the publication process and how those licenses are expressed to the end user. Then there's all the interoperability and validation rules that occur during the development time. And then last but not least, there's the publication of that API or service into a portal or into a repository within the organization. So you can see how policies and how workflow are very, very relevant to this particular use case within an organization. We're controlling the workflow process as well as all of the standards and compliance processes within that workflow process. So let me look at licensing for a second. The goal of licensing is to enable a business model. So an organization, for example, wants to enable or monetize their API based on different operations or resources and different levels of service. And what they want to accomplish is when a developer logs on to the repository or logs on to the developer portal, they want to display these licenses to the developers. So they might come up with a creative platinum, gold, bronze licensing model, and they want to actually display this, represent it to the developer, and get the developer to choose one of those licensing models when they're trying to gain access to the API or service. So the license itself is there as a business representation of a set of underlying policies. And those underlying policies control the runtime entitlements, the documentation visibility, and the quota policies associated with that particular provisioning action. So if a developer comes in and says, I have a new app and I want to connect my app to your API and I want the silver level of service, then perhaps we're only going to show them a subset of the documentation. And perhaps we're only going to show them or give them certain runtime entitlements to certain APIs. And we're also going to control how many times they can call that API over an interval. So if you look at the little screenshot on the right, you can see that I've created certain license definitions, and within that are certain scopes which control the runtime entitlements, and then certain profiles or policies that say how many requests per second and what the response time should be guaranteed for that particular licensing model. So this shows you how a business concept of licensing really relates to policies that underlie a system. I mentioned briefly quotas, but quotas are all around enabling that same business model as licenses, but at the same time also protecting your organization. So you want to create different licenses, and those levels of service are typically around throughput, bandwidth consumed over time, concurrency allowed, and availability of a particular API or service. You can then, when that particular quota is exceeded, either cut off an application or generate events when quotas are exceeded. A fun example here is overage billing. So you might expose an API or service to a set of consumers with a particular license, and then built into that license is a certain amount of overage billing. You need to know when that service level or when that quota is exceeded so that you can then bill them for that overage. And this all comes down to defining certain quota policies in the environment and associating them with licenses. So last but not least is around security mediation. This is the last use case that I'm going to discuss. And the goal of security mediation is to use policies to lower cost and risk. Say, for example, you have an API exposed externally that has a security policy of OAuth that uses SAML2 as a token type. Internally, however, you're taking that API and you're routing that API call and transforming that API to make an internal SOAP WSS call. And that SOAP WS call is expecting a web services security token, a SAML security token within that SOAP call. So what a good system can do is actually use these two declarative policies to automatically convert inbound credential types such as OAuth, the inbound OAuth tokens, to the outbound WSS SAML security token that is needed by the downstream services. So this is kind of a 1 + 1 = 3. If you define your policies effectively for internal services and external services, the API gateway or the platform that you have internally doing the mashups and doing the orchestration and composition can automatically convert the two token types by reading the policies inbound and outbound and making an intelligent decision about how it needs to transform that security token. And this is something you get when you define the policies and when you enable security mediation in the platform. Last but not least, of course, is edge caching and paging. If you have a mobile app that's globally distributed, traditional CDN and acceleration services can't really provide edge security for REST APIs. So you need a plan or infrastructure that can actually improve performance by providing caching close to the application. And for mobile apps in particular, you need to implement paging policies that can break up large collections of data within backend messages and present that to mobile applications in small bites. So you need an infrastructure that both understands API security policies that can deliver edge caching and deliver edge paging for mobile devices. And the goal of that and the benefit of that is to improve performance. So one of the platforms that provides that is, of course, our platform. And we have a platform that provides all of the capabilities from lifecycle management, service integration, gateway services, developer engagement, and analytics. And you're welcome to come to our website and take a look at our offerings both as a service as well as on-premise to hopefully meet your needs. So in summary, policy management will basically help your organization simplify and automate app publication, reduce complexity, speed up development, enable a business model, protect your business, protect yourself, lower cost and risk, and improve performance. All of these things can be done through policy and a good system that understands how to define and enforce those policies. And with that, I say thank you very much. My name is Alistair Farquharson. I'm the CTO of SOA Software, and you can reach me as follows. And that concludes my formal presentation. I'll hand it back to you, Vance.
Alistair, thanks very much, especially for a very, very important look, I think, at a lot of the mechanisms that run under the covers a bit to how businesses and even IT admins get the most from them. So a really revealing session. Thanks a lot.
It's always a pleasure.
Speaking of business and IT, we've kind of got a mix of both types of questions. So with your permission, let's turn right to questions.
Sounds good.
So, Alistair, let's kick off with a question that I think might begin a good conversation about the importance of policy for both API and SOA projects. And the question here says, can the speaker explain the differences between using policy or a simple API portal security approach to manage how our APIs are used by developers and outside partners?
Sure, Vance. I think that the key here is all around licensing. So I would say that for the first time, policies have really direct business relevance. If I'm trying to create a business model for an API or service or a B2B service, then my business model needs to be encoded inside policy. And a good policy management system allows you to create that association between business model and underlying policy.
You know, you really bring up a conversation similar to this when you talked about the life cycle, both the API and the SOA life cycle. And a question comes in which I think taps into the same theme of business value from policy. And the question says, to ensure my SLA or high performance, where should I use policy? In design time, runtime, or both?
Definitely both. So during design time, what you're going to do is you're going to be asking people questions, maybe literally or figuratively, but basically during design time, you're going to be questioning the developer and the business analyst and asking them, what SLA do you want? What are your parameters for this thing that you're exposing? So the business analyst then is forced to make a decision about the quality of service that they want from a particular service. And that's done during design time. Then what happens at runtime is that design time business decision is translated into policy. You need to decide as an architect or as an IT administrator what questions you want to pose to the business analyst or the business folks to be able to determine what policies are enforced. And those criteria need to be encoded in the platform. So you need a form that they literally have to fill out that says, what kind of customer is this? Are these people going to be using this thing globally? What kind of SLA are you promising to these people? Because the business people ultimately are going to be writing the legal docs as well, which specify a certain SLA. So these questions need to then generate, at the end of the day, the actual technical policies that get applied to the environment. There's basically three components to the system, which we have. The first is a lifecycle management tool. We call it Lifecycle Manager. But the lifecycle management tool is the tool that the developers and the business analysts interact with to describe the requirements and the objectives behind a particular service. So this is a tool that reaches out and actually manages the lifecycle of an API or an app. And it's literally going to ask the questions of the business analyst that are required to determine policy. Then the technical policies are authored in our policy management system. So this is where you'll go and you'll create the technical policies around quotas and SLAs and OAuth, security policies, et cetera, and that's the policy manager system or product. Then there is the developer community product, which is the one that deals with licenses. So your outbound channel, your public-facing channel, or your partner-facing channel. This is where you go and define licenses and correlate those licenses to the underlying technical policies for quotas and SLAs. And then last but not least is the gateway itself that intercepts the messages on the wire and enforces all of those policies. So there's different tools for different roles. The policy administrator, the developer, the business analyst, the partner that you're dealing with. So what we're trying to do is make things faster. We're trying to get the control that everybody wants and needs, but at the same time, we're trying to create a factory that can push these things out quickly and simply and easily and in a well-understood manner.
Excellent conversation, Alistair Farquharson, CTO of SOA Software. Thanks very much for this really eye-opening look at how policy in the API era has gotten much more powerful and easy to implement, and especially for taking so many questions. We really appreciate it.
Oh, no problem.
And as we love to do here at SOA Summit, we're going to have a summary slide of some terrific links to the technical material as well as the product material that Alistair references in his session. So thanks again, everyone.